Hello everyone, greetings from VNR VIGNANA JYOTHI Institute of Engineering and Technology. This is Manohar Reddy, Department of Cybersecurity, Data Science and AIDS. Today in this session I am going to explain about the concept of CRC code computation using CRC-12 polynomial method. So generally what is meant by CRC and where it occurs, in which layer it is presenting, and what is the importance of this CRC, we are going to discuss in this session. So CRC is an error detection technique. So error detection technique, as the name itself, we are when we see the all layers responsibilities in the data link layer, the error detection is the one of the responsibility of data link layer. So how the frames are transferred in the form of bits, and how when the error is occurred. So to identifying that error, one detection technique is required. So CRC is such type of error detection technique, and it is used in computer networks and digital communications to detect accidental changes in the transmitted data. So from the sender to the receiver, the data is transmitted like zeros, ones, zeros, like this. Whenever this data is transmitted through this channel, the receiver may get the same data or some misused data, or same data or some changed data. So how it knows how this changed data is done to some changes on the receiver side? Is the data is to be changed or the same original? So how do we check? So that is the process we are going to establish the error detection technique. So we are going to introduce the error detection technique here. So when data is transmitted, the sender computes CRC code. The sender computes, that means calculates the CRC code reminder, and appends it to the data. The receiver performs the same computation process. If the reminder is 0, after performing the same computation process, if the reminder is 0, then data is assumed to be error free. So that may not be changed any accidental, or that may not be altered during the transmission. So if the reminder is 0, the data is assumed to be error free. If the reminder is not 0, then the data is assumed to be some error. So then the error detection technique is helped. So these are all some CRC types listed below: CRC-12, 12 polynomial, CRC-16, 16 polynomial, and CCITT is 16 polynomial. So these are the polynomial techniques, CRC polynomial techniques that we can compute to use. So how the CRC working principle? So how the CRC computation will be processed? So in the steps wise, if you see, the first step is what? Choose the generator polynomial. So if anybody having receives the data 01 or 10 something, if you receives any of these data and compute or perform with particular CRC, CRC-12 or particular CRC-16, then the first you can choose the common CRC polynomial. So out of this CRC-2, CRC-16, CCITT, choose the appropriate polynomial. The next, append the zeros. So here the generator polynomials are what? This one. So x power 2 plus x power 11 plus x power 3, x power t, x power 1 plus 1. This is the CRC-12 polynomial. And this one CRC-16 polynomial, and this one CRC-16 CCITT polynomial. So the polynomial and these binary bits are described here. So the polynomial consists of total 13 bits. So 12 CRC-12 bits, or CRC-12 generator polynomial consists of 13 bits, and CRC-16 polynomial consists of 17 bits, and CRC-CCITT polynomial also consists of 17 bits. So now when you are performing the computation process, you can add all these binary bits. The step 2 is what? Append zeros. If the generator has a degree R, so based upon the degree of R, the append R zeros to the data. Suppose if you have the degree of 12, then you can add CRC-12 polynomial, 12 zeros to append the data. So take an example here. The data is what? 1101, 0110 and 11. So here total 10 bits are there. So for these 10 bits, you can append 12 zeros as the CRC-12 process. You can choose the CRC-12 because of the degree of the, based on the degree of the data. So now the CRC-12 is appended to the data, entire data. So 1101, 011, 011, that is the original data, and appending these 12 zeros to the particular data as it is the having the degree of 10. It is having the degree of 10. After appending zeros, the next thing is what? Perform the binary division. Perform the binary division, that is performing XOR division using the generator polynomial. So here, when you are performing these division operations, the following rules to be applied. When you are performing 0 XOR with 0, then the result will be 0. When you are performing 1 XOR with the 1, you can output will be 0. And the performing 0 XOR with 1, then the output will be 1. Performing 1 XOR with 0, the output will be 1. So here, out of these all, when 0 and 0 performing the XOR operation, the result will be 0, and 1 and 1 will be performing XOR, then the result will be 0. And remaining 1 or 0 and 0 or 1, then you can perform 1 as the output. And no carry and no borrow. So that is the step 3, performing modulo 2, binary division. And step 4 is what? Obtain the remainder. So after performing all these calculations, till you will get the 12-bit remainder as the CRC remainder. So obtain the remainder. The remainder is the CRC code. The first CRC-12, the remainder is what? 12-bit remainder. You can calculate the computation. You can know that 12-bit remainder is the CRC-12 remainder, and 16-bit remainder is the CRC-16-bit remainder. And also for CRC-CCITT, 16-bit remainder is the remainder. After getting the remainder, the performing the step 5, transmit. So transmitted frame is what? Original data plus CRC remainder. So original data is what? If you see, the original data is what? This one. So append that original data to with the CRC remainder. So obtain 10110010. This is the original data plus CRC remainder, that is 12-bit or 16-bit based on the calculation. Suppose if you have this is the 12-bit remainder, then you can add this 12-bit remainder to this original data. So this is the transmitted frame. Like this, you can use the computation methods. So how you are calculating? First, choose the generator polynomial. Then next, second, append zeros. So how you are applying the zeros based on the generator has the degree of them. The next, performing binary division modulo 2 operation. The next, performing obtain the remainder operation. After getting the remainder, after having the data, you can transmit the frame. Transmitted frame equals to original data plus CRC remainder. This is the transmitted frame from the data link layer to next physical layer. So how we can see the example how CRC2 computation will be having the process. So here, as per the steps we are following, the given data is what? 10110 and 10111. This is the data we are computing the data with the help of CRC-12 computation example. So the data is what? 10110 and 10111. We are having the degree of what? 10. So we can use the 12 generator. We can use the CRC-12 generator. So 11, 000 and 0001 and 11. This is the CRC-12 polynomial generator. How it comes means you can see the generator polynomial x power 2 plus, like that. You can see all this from this one, x power 12 plus x power 11. From this you can see this is the CRC-12 generator bits. Append 12 zeros to the transmitted data. Append 12 zeros to the original data. So this is the original data, and append 12 zeros because the CRC-12 generator you are appending 12 zeros to this data. So now the data is what? Dividend. This is called as dividend and this is called as divisor. So the divisor is what? CRC-12 generator, and the dividend is what? You are appended 12 zeros data. So here this is the original data and these are the 12 appended zeros. Entire this one is what? Dividend. This is what? Dividend, and this is the divisor which is coming from CRC-12 generator. Now performing the operation dividend XOR with the divisor. performing the operation dividend XOR with the divisor. So during this process 1 and 1 is what? 0, and 0 and 0 is what? 0, and 1 and 1 is 1 and 0 is what? 1, and 0 and 1 is what? 1. These are the outputs when you are performing. These are the output bits when you are performing this XOR operation with the 1 and 1 or 1 0 and 1. So now how we can compute all these things? So first, performing XOR operation. Step 1. So take the first 13 bits from this entire bit. So take all from 13 bits, take all this data and take 13 bits from this data. So take 13 bits, 1 0 1 1, 0 1 0 1, 1 1 0 0. That is the first 13 bits of the data. And this is the dividend, this is the divisor, and this is the dividend. So dividend contains 13 bits data and divisor contains based upon the 13 bits. So when you are performing the XOR operation, 0 and 1s 1, 0 and 1s 1, 0 and 1 1s 1 1 0, 1 0 1, 1 0 1, 0 0 0, 1 0 1, 0 0 0, 1 0 1, and 1 0 1, 1 0 1 and 1 1 0. So like that you can perform the operation XOR operations to the both dividend and divisor, performing both the dividend and division with the XOR operation. Now after receiving all these things, drop the leading 0, that means drop this leading 0 and bring down to the next bit. So after removing this one and we can bring down 0 from the remaining zeros, then the data will be like this: 1 1 0, 1 1 0 and 1 1 0. This is the next bit. Since out of all this data, since the leftmost bit is 1, perform XOR again. So 1 1 0, 1 0 1 1, 0 1 1 and 0. This is the data, and the divisor is what? 1 1 1 1 0 0 0 0 0 0 1 1 1 1. So perform XOR operation with this one. Same, perform operation with this one. Same, 0 and 1 1. So wherever you can see the 0 will be occur whenever 1 and 1 and 0 and 0 are there. Wherever the 1 will be occur, 1 and 0 and 0 and 1 are there. So this is the output. This is the output from this step 2. And here drop leading 0 and bring down to the next bit. So here drop this leading 0 and bring down the 0 will be occur here. So now the data will be 0 1 from this 0 1 0 1 0 1 1 0 0 0 0 1 and 0. This is the bring down 0 to the next level. Perform this operation. Leftmost bit is what? Here leftmost bit is what? 0. So do not perform any XOR operation. Shift left and bring next bit. So you can shift left to the right side and you can perform next bit. You can bring next bit. So now the next bit is what? Now 1 0 1 0, 1 1 0 0 0 0, 1 0 0, and with the divisor operation performing. So now the output will be 0 1 1 0, 1 1 0 0 0, 1 0 1 1. So from this bring next bit 0 to the this one. So because the leftmost bit is 0, no need of XOR operation. So bring down the next bit is 0. So the next bit will be added. So 1 1 0 1 1, 0 0 1 0 1 1 0. This bit will be added. And next perform XOR operation with the same bit and dividend operation. So after performing this one, the output of this is what? This one: 0 0 1 1, 0 0 1 1 0 0 1. So again leftmost bit is 0, so no need of performing XOR operation. Then bring next 0 to here. So 0 0 1 1, 0 0 1 1, 0 0 1 0, bring the next one. And here also leftmost bit is what? 0. So shift, no need of performing XOR operation, shift them. So 0 1 1, 0 0 1 1, 0 0 1 0 0. And leftmost bit is still leftmost bit is 0. Shift that one. So performing shift operation, then 1 1 0 and 0 0 1 and 1 0 0 and 1 0 0, and this shift bit is added here. So 1 0 0. And step 5 same. Again here you can see the leftmost bit is 1, then perform XOR operation. Perform XOR operation with the same division and divisor, then you will get the output. and bring the next bit. Here leftmost bit is what? 0. So no need of performing any XOR operation. So then bring next bit 0 to the down. So 0000 11 000 111 and 0 will be added here. Shift until all bits are processed. Shift until all bits are processed. So till all complete bits, remaining bits, 0 bits will be added. The final 13-bit value becomes 00011 So ignoring, out of all this, ignoring the leading 0, that is leading 0 gives, and the remaining 12 bit value is the remainder. So we have to process the step till all the bits. We have to process till the all bits are arranged. We have to perform the entire steps. Once we reach the last step, in the last step, out of all the values, if the value is what? Left side bit is 0, then ignore the leading 0 and take the 12-bit remainder. That is this 12-bit remainder, 0011 000 11 100. So here this is the 12-bit remainder. This is the 12-bit remainder is what? Obtained remainder. This 12-bit remainder is what? Obtained remainder. Now therefore CRC remainder will be this one. After that, step 5 is what? Transmitted code word. So transmitted data is what? The data, completed data plus obtained remainder. So complete data is what? 1011 0 That is the data, and for that data we are adding obtained remainder, that is what? 0011 000 111 So that will be added to this one data. So now the entire data is what? This one. This is the transmitted code word. This is the transmitted data to the next layer. Like this you can compute all the CRC-12, CRC-16, CRC-CCIT process. So we need to calculate, we need to perform all the operations till all the bits are engaged. So once all the bits are engaged, the final bit value is what? To become 13-bit value for the CRC-12. Then only you will obtain the remainder. So after obtaining the remainder will be added to the data. So that will be the transmitted code word. So this is the way you can calculate the CRC-12 process and CRC-16 process also. Thank you all.